What a wonderful day, grade 7 learners! How are you today? I hope you are doing great. Today is a new day to learn how to describe principal roots and tell us whether they are rational or irrational, and how to determine between what two integers the square root of a number is. As we start today's discussion, I want you to bring out your ballpen, your self-learning module, your scientific calculator, and your learning activity sheet. Are you ready to have fun while learning? Let's begin! It is time for us to explore the concepts of principal roots and irrational numbers. Using a scientific calculator, input the following and get the equivalent. Round off your answers to the nearest hundreds. Number 1, square root of 36. Number 2, square root of 50. Number 3, square root of 2. And number 4, square root of 75. And number 5, square root of 81. Timer! Let's check. Square root of 36 is equal to 6. Square root of 50 is this. If we round it off to the nearest hundreds, that would be 7.07. Square root of 2 is this. If we round it off to the nearest hundreds, that would be 1.41. Square root of 75 is this. If we round it off to the nearest hundreds, it is 8.66. And square root of 81 is 9. In your activity, have you noticed this symbol? It is used to extract the principal root of a real number. This symbol is known as the radical sign. The combination of the radical sign together with the number is called a radical. The number under the radical sign is known as the radicand. In this symbol, there is an invisible number 2 here, which indicates that we are getting the square root of the radicand. This number is known as the index. It can be any positive integer. If the index is 2, no need to write it. Here it is. Let's study the table below. We have the radical and the radicand. When we extract the square root of 2 and square root of 3, that is called the principal root. Let's define more. Principal root is a number which produces a specific quantity when multiplied by itself. It is the positive nth root of a number. A perfect square is the square of a rational number. Rational number is a number that can be expressed in the form a over b, where a and b are integers, and b is not equal to 0. Irrational number is a number whose decimal representation is neither terminating nor repeating. This number cannot be expressed as a quotient of integers. Earlier in your first activity, you try to get the equivalent value of the given radicals using a scientific calculator. You have known that the equivalent value is called the principal root. Notice that some of the principal roots are whole numbers, while some are decimal numbers. That means when a principal root is a whole number or fraction, then the principal root is described as rational. When the principal root is a non-terminating or non-repeating decimal number, then the principal root is described as irrational. To determine whether a principal root is rational or irrational, we need to get first the principal root of a number. We can use a scientific calculator to get the exact principal root of a certain number. And tell if it is rational or irrational. We can also use the concept of perfect squares to separate rational from irrational principal root. When a number is multiplied by itself, the result is a perfect square. Let us take a look at this activity. Determine which of the floating boxes is the square of the given numbers. You can do this by multiplying the number by itself. You have 20 seconds. Timer! Let's check. Let's check your answer by pressing it on a calculator. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Great job! All of the derived products are considered perfect squares. Moreover, taking the principal root of a number is like doing the reverse operation of squaring a number. When 1 squared equals 1, then the square root of 1 is 1. When 2 squared equals 4, the square root of 4 equals 2. When 3 squared equals 9, the square root of 9 equals 3. When 4 squared equals 16, then the square root of 16 equals 4. 5 squared equals 25, then the square root of 25 equals 5, and so on. Now, since we have extracted rational numbers, we can say that the principal root of all perfect squares are rational. On the other hand, when a number is not a perfect square, then its principal root is irrational. Let's look at these examples. Square root of 2. Can you think of any number that when multiplied by itself will give an answer of 2? None. We can say then that 2 is not a perfect square. Extracting its principal root, it is non-terminating and non-repeating decimal number. Therefore, the principal root of square root of 2 is irrational. Number 2. Square root of 15. Can you think of any number that when multiplied by itself will give an answer of 15? None. We can say then that 15 is not a perfect square. Its principal root is non-terminating and non-repeating decimal number. Therefore, the principal root of square root of 15 is irrational. Number 3. Square root of 3 over 10. Can you think of any number that when multiplied by itself will give an answer of 3 over 10? None. We can say then that 3 over 10 is not a perfect square. Its principal root is non-terminating and non-repeating decimal number. Therefore, the principal root of square root of 3 over 10 is irrational. Now that you learned the concept of principal roots and irrational numbers, it's your turn to answer. Determine whether the principal root of number is rational or irrational. Number 1. Square root of 3. What is your answer? Since we extracted an irrational number, the answer is irrational. Number 2. Square root of 26. What's your answer? The correct answer is irrational. Square root of 121. What's your answer? Since we extracted a rational number, which is 11, the principal root is rational. Number 4. Square root of 6 over 21. What's your answer? Since the extracted principal root is irrational, the correct answer is irrational. And number 5. Square root of 25 over 64. What's your answer? The correct answer is, since the extracted a rational number, which is 5 over 8, then the principal root is rational. You did great, Freshies! You should know how to get the principal root of a given number and memorize the list of perfect square integers. I know you can do it. Now, let's get into finding the two consecutive integers where the square root of a number lies. But how can we do it? If a principal root is an irrational number, the easiest way we can do is to determine between what two integers the square root of a number lie. Let's have an example. Find two consecutive integers where square root of 12 lies in between. Think of two consecutive perfect square integers where 12 is in between them. 12 is between the perfect squares 9 and 16. Now, take the square roots of these numbers. Square root of 9 equals 3, while square root of 16 is 4. Thus, the principal root of square root of 12 is between 3 and 4. It's so math dali. Another example. Find the closest integers where square root of 40 lies in between. Again, think of two consecutive perfect square integers where 40 is in between them. 40 is between the perfect squares 36 and 49. Then take the square roots of these numbers. Since square root of 36 equals 6 and square root of 49 is 7, thus, the principal root of 40 is between 6 and 7. It's your time to answer this. Determine the two consecutive integers where the square root of 175 lies in between. Timer! If your answer is between 13 and 14, your answer is correct. Congratulations, students! You made it this far. So, here are the things that you learned today. That's it for today. Again, this is Teacher Lori, your math buddy. I hope you learned a lot here at Math Pinadali.